For any assignment-related queries, call us at +1 678 648 4277. Visit https://www.architectureassignmenthelp.com or email support@architectureassignmenthelp.com. Problem 1. The MIPS pipeline below implements a hypothetical MIPS times JR instruction. The hardware for times JR is shown in blue. Don't confuse times JR with the existing MIPS JR instruction. A. The diagram shows a warning in red with lots of arrows and an explanation. Alas, the explanation is covered by the format IMD box. Assume that the hardware 4 times JR is correct. Then what can the warning be about? Reason for warning. The warning is probably about the critical path, which passes through the IF stage memory port. The address input to a memory port should be available at the beginning of a clock cycle, but in the times implementation the IF stage memory port address is taken JR from the register file, and that adds too much to the critical path. For the record, the text under the format IMD box says, blah blah blah. architectureassignmenthelp.com. Problem 1, continued. B. Note, this part did not appear on the exam because the exam was already long enough. There are 2 differences between times JR and junior fragment A. Below, uses junior complete fragment B so that it uses times JR, making changes to account for these 2 differences. Fragment B must jump to the same location and perform the same computation as fragment A. Register R9 can be used for intermediate values. Hint, the differences are when and where. Complete code, or for partial credit, explain 2 differences. Solution appears below, and the implementation of the ordinary JR instruction is shown above in purple. The JR1 instruction jumps to the address in R1 after the delay slot instruction, in this case ADI R2 is executed. The hardware in purple above shows the path used by the JR instruction. It carries RSV, the RS value, in the example the value of R1, from the register file, in ID, to the PC mux, in IF. As is done with the branch and jump targets, the 2 least significant bits of the RSV are not used since. architectureassignmenthelp.com. JR1 instruction is different in 2 ways. First, it jumps to the address 4*R1. That's because unlike the path used by JR, the 2 least significant bits of the register value are retained and 2 zeros are prepended to the less significant side at the input to the IF stage memory port. The second difference is that the target address 4 times JR is at the input to the memory port when times JR is in ID, meaning that the target is in IF while the times JR is in ID, and so the target is fetched 1 cycle earlier than JR, and 1 cycle earlier than the branch instructions. This also means that times JR lacks a delay slot. So that fragment B jumps to the same address as fragment A, the address must be shifted right by 2 bits. Because times JR lacks a delay slot, the delay slot instruction for JR, ADI, must be moved before the times JR. Problem 2. The code below executes on the illustrated implementation. The implementation has hardware that enables the bean to avoid the stall, but that hardware is not shown. architectureassignmenthelp.com. A. The illustration has several circled letters pointing to wires. In the diagram below show the values on those wires on each cycle the value is used. Solution appears below. In cycle 7 the B row, the immediate, shows the branch displacement, -6 instructions. For the C row it is important to show zeros for instructions that don't write a register, SW, and bean. Loop, hashtag cycle 0 1 2 3 4 5 6 7 8 9 10 11 Lu R1, 8, R2, if IDEX me WB ADI R2, R2, 2 if IDEX me WB add R3, R1, R3 if IDEX me WB SW R3, 12, R6 if IDEX me WB SLT R5, R3, R4 if IDEX me WB. ArchitectureAssignmentHelp.com. B. For each dependency below highlight, on the illustration, the multiplexer input that provides the bypassed value. Also indicate the cycle in which the bypass occurs. Dependence from one hoop to add R3. Bean R5, R0 loop if IDEXME WB hashtag no stall. Next prob. Add R6, R6, for if IDEXME WB. Hashtag cycle 01234567891011A, 2216356 hashtag solution B, 8212-64 hashtag solution C, 1230506 hashtag solution hashtag cycle 01234567891011. Dependent cycle when bypass used. From one hoop to add R3. Dependence from add R3 to SW. Dependence from add R3 to SLT. Solution appears in the implementation diagram in purple. Cycle when bypass used. Cycle when bypass used. Cycle when bypass used. Problem 3. In the previous problem, the bean did not stall despite a dependence with SLT. Code with a similar dependence appears below. Add hardware to the implementation below that correctly sets the taken signal for such SLT-RX, RE, RZ to bean RX, R0 dependencies. Branches without the dependence should not be affected. Note that the result of SLT is 0 or 1. Some useful hardware is shown in blue. ArchitectureAssignmentHelp.com. Add logic to set taken correctly for the dependence described above. Avoid costly solutions. No part of the solution should operate on 32 bits. Check that the second branch register is R0. Branches without the dependence should not be affected. Solution appears below in purple and orange. Sample instructions are shown in green. The inputs to the big and gate from top to bottom check for the following: 1. That the instruction in ID is a bean. 2. That the RT register of the branch is R0. 3. That the RS register of the branch is the same as the destination register of the instruction in EX. 4. That the instruction in EX is an SLT. And 5. That the SLT result is 1, meaning that the condition is true. To reduce hardware cost, the logic checks whether RT equals 0, a 5-bit comparison, rather than RTV equals 0, a 32-bit comparison. Note: the following is the solution to 2019 Homework 5 Problem 2. If the SLT/bean dependence is detected, then the branch taken condition computed using RSV and RTV, using the equals logic, needs to be ignored. To do so, a new bubbled input, shown in orange, has been added to the AND gate computing the bean taken condition. That input only checks for the dependence, ID stage RS with EX stage destination. It doesn't matter what instruction is in the EX stage, if there's a dependence, that taken signal should be suppressed. ArchitectureAssignmentHelp.com. ArchitectureAssignmentHelp.com.